Now, the next thing we're going to be looking at with our rational expressions and rational equations, mainly we're going to focus on rational expressions first. One is simplifying, and two is our operations, being able to add, subtract, multiply, divide. So before we get to operations, we're going to look at simplifying. Simplifying a rational expression. We're going to simplify it so that the numerator and denominator, the top and bottom of the fraction, has no common factors, nothing in common with it other than 1. Simplified form is when its numerator and denominator have no common factors other than plus or minus 1, positive or negative 1. There's nothing else that we can take out of besides either a positive 1 or a negative 1, just a sign change. Nothing else is in common. Because if there is something in common on top and bottom, we need to reduce it out, we need to simplify it. Really all this is saying is that, well, if I can write, leaving your answer as 8/6 is not going to work because there is a common factor of 2 on top and bottom. It has to be reduced out. If there's something in common, if there's an expression in common on top and bottom, it has to be reduced. So the property here, AC over BC, since C is in common on top and bottom, we would reduce the C out, leaving us with A over B. Now, the same thing is true with full expressions. We could have 4 times x plus 3 over x plus 3 times x plus 3. One of the x plus 3's would simplify out, giving us just 4 over x plus 3. If there's something in common on top and bottom, we have to reduce it. And they don't list it here, but also, especially when we start solving, we will have something called restrictions. Because in this expression, x, especially here, x can be any value, but any value of x that would make the denominator be 0 has to be removed. We cannot have a divisibility of 0. We can't have the denominator be 0. And the way to find that is just taking our expressions on bottom, which ends up being just x plus 3, setting it equal to 0 and solving. So we would subtract 3, telling us that x cannot be negative 3. Because if x is negative 3, this set of parentheses here would become 0, which would make the whole denominator be 0, causing us to divide by 0. We can't have a division of 0. Questions on this so far? Now, they don't have it listed here, and it's kind of funny because, well, since the final expression has x plus 3 on bottom, it's still showing us that x cannot be negative 3, so they don't list it. They only list it if that expression has been removed. It's not listed anymore, it doesn't show up anymore, then they want the restricted listed. If it's still there, they say we can keep it out. I don't see why not just list them both anyways. Now, for the most part, listing the restrictions isn't going to be essentially crucial. It will be, especially when we start solving. Because if a solution, if a value that would make this statement true or we find when solving comes up, it's removed because it's not possible. It would be an extraneous solution. It's a solution we get from solving, but does not work in the original context. So, let's look at the first one here. We have 4 over x times x plus 2. Is there something in common, either a number or term on top and bottom? No, you're good. No, 2, because we do have, yes, we have 2 inside the parentheses here, and 4 does have 2, yes? And unfortunately, we can't simplify those. And this is one of the big things with this, and it comes up, is that because the bottom x plus 2, we have those added together, they're considered one expression. So x plus 2 is stuck together. We can't just say that this is going to become 2 and this is going to become 1 because they're stuck together. Now, if that 2 had been out front with the x, 4 over 2x, we can split those apart. We can reduce those down. But unfortunately, we don't have anything there. Was there anything in common left? No. This is, I can spot. This is simplified. There's nothing we can do with it. We did need to factor it, because if it was factored in any way, shape, or form, we need to factor it to being able to be sure. We need to make sure 100% that there's nothing in common on top and bottom. If there's not, this is it. And even if there wasn't, and we factored and found that there wasn't, leave it in factored form. There's no reason to multiply it back out if we already factored it. All right, let's actually look at one here. We have 2 times x plus 1 over x plus 1 times x plus 3. Is there something in common on top and bottom? X plus 1, we have this x plus 1 in top and bottom. Now, I'm going to show you simplifying it. You don't have to do it this way. We're not going to do it this way after this. I just want to show this so we know. Whenever we multiply 2 rational expressions together, we multiply top with top and bottom with bottom, yes? Well, that means I can split them back apart. Because on top, we have 2 times x plus 1. Which is just the same as this here, yes? Are we comfortable with saying that? On bottom, we have x plus 1 times x plus 3. So really, because they are being multiplied, I can write them as these 2 separate fractions. Yes? But the one on the right is now what? X plus 1 over x plus 1. Anything divided by itself is 1. So this whole expression is just going to become 1. And well, 2 over x plus 3 times 1 is just 2 over x plus 3. So because those are being multiplied, the 2 and x plus 1, the x plus 1 and x plus 3 are being multiplied, realistically, we can split it to 2 fractions. X plus 1 over x plus 1 reduces to 1, leaving us with 2 over x plus 3. Yes? We see how that works. Or how the fact that they're in common on top and bottom in multiplication lets us be able to reduce it and remove that term from top and bottom because it is shared. Okay? Questions? Now again, I said we're not going to do it this way every single time. Because seeing this here shows us that yes, since that's on top and bottom, they're being multiplied, they will reduce out, yes? That means that these will just go away anyways. Telling us that this is just 2 over x plus 3. I wanted us to see the fact that we can break it apart because they're being multiplied, not added or subtracted. That we can get x plus 1 over x plus 1. They will reduce to 1, simplify out. Since we know that, we can cross them out because of multiplication, giving us 2 over x plus 3. Questions on this here? Restrictions. Restrictions are values of x that we cannot have. Because when we talk about expressions, especially like this here, what x can be is any real number. That's the way this just works with an expression. So we're saying that any value of x we can plug in here and it's going to make it true, but again, we cannot have the denominator be 0. We cannot divide by 0. So the 2 places where we can have a division of 0 is here and here. So if x plus 1 is 0, we would have a restriction for whatever that value is. The same would be true for x plus 3. So we can set them equal to 0, solve for x, and find the restrictions, the values of x that would make this function be 0. Well, with x plus 1, we would subtract 1, telling us that if x is negative 1, we would have a denominator of 0. So x cannot be negative 1. X plus 3. We would subtract 3 from both sides, telling us if x is negative 3, the denominator would be 0. That does not work. So if we were to list the restrictions for this here, it would simplify to 2 over x plus 3. And we'd say x cannot be negative 1 and x cannot be negative 3. This book and some other books would just say the restriction is x is not negative 1. Yes. And the reason they would include this one but not this one is they say, well, x plus 3 is still listed in the expression. So you should be able to see that, well, if x plus 3 into the negative 3 make it have the denominator of 0. Since the x plus 1 simplified out completely, it's not listed, but it is a restriction from the original problem. It just does not work. Okay? Are you ready for the next one? All right. Well, this one here, they did not give it to us in factored form. Again, this is why, before we started the chapter, I hit factoring one more time, because a lot of times, and most of the time, they're going to give it in this form, not factored form. So the first thing we're going to have to do is actually factor the top and bottom of this fraction to see if there's something in common on top and bottom. And the biggest thing I would say with this here is start factoring, or start with whichever one you see the factors of first. Whichever one. And we can start with the bottom, x squared minus 4. X squared minus 4 is our difference of perfect squares. Two things being subtracted, which is our a squared minus b squared, which factors a plus b times a minus b. Because what times itself is x squared? X, so we have x and x. What times itself is 4? 2. So x squared minus 4 is going to factor to x plus 2 times x minus 2. Now again, the reason I say start with whichever one we can see the factors of first, or the ones that comes to us first, is again because if something's going to reduce, if it's going to be able to simplify, I need one of the factors on top to be what? Either x plus 2 or x minus 2. Because we have to have something in common on top and bottom to simplify. So now when I go to factor the top, to factor this numerator, x squared minus 4x minus 12, if it's going to work, and something's going to simplify, it's going to have to be either x plus 2 or x minus 2. Let's find the signs on top, because there is no greatest common factor between x squared, 4x, and 12. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, which it is, our signs are opposite. One's going to be plus and one's going to be minus. Factors of x squared. We only have one set, x and x. Now the factors of 12. 1 and 12, 2 and 6, 3 and 4. Which one of these sets of factors do we want to try first? 2 and 6. 3 and 4, 1 and 12, they might work. But if they do, there's no way for me to get a set of parentheses on top that's what? X plus 2 or x minus 2. Because if it works like out this here, if it was x plus 2 times x minus 6, it might be, it might not. We do now have a common factor of x plus 2 on top and bottom. It's giving me hints. It's giving me options that might work. X times negative 6 is negative 6x. 2 times x is plus 2x. And negative 6x plus 2x, negative 6 plus 2 is negative 4. That is the middle term we wanted, yes? So that tells us these are the correct set of factors. We do now have something in common. We have something in common that we can reduce out of both. But the biggest thing with this here is I found the factors of the one that I could see first, x squared minus 4. And doing that helped guide me to the correct factors on top, because I don't have to look at the factor of 12 with 3 and 4, 1 and 12. 2 and 6, because if something's going to simplify, it's got to be either x plus 2 or x minus 2. It gave us a map to a possible setup. Now, if it had been x plus 3 times x minus 4, there's nothing in common. We're done. It's simplified. But because x plus 2 is in common on top and bottom, we could write it the same way we did before. Have the x plus 2 over x plus 2 as one fraction, and then it's multiplied by our x minus 6 over x minus 2. Now, the x plus 2 over x plus 2 will simplify to 1. And that leaves us with x minus 6 over x minus 2. Now, unfortunately, at this point here, we can't simplify farther than that. Because, yes, we do have the 2 and 6. But the 6 on top is stuck with that x because of addition subtraction. The 2 on bottom is stuck with that x because of that subtraction. They're stuck together. And we get this here. Questions on this here? Now, if we wanted to look at the restrictions, it'd be the values of x that's going to make the denominator be 0. And we have two places, the x plus 2 and x minus 2. Because whatever value is going to make x plus 2 be 0 would cause the denominator and the numerator to be 0, but because the denominator is 0, we cannot divide by 0, even if what is being divided by is also 0. So with our x plus 2, to get x by itself, we would subtract 2, telling us x cannot be negative 2. With our x plus 2, if we added 2 to both sides, it'll tell us that when x is positive 2, we would get a denominator of 0. That does not work either. Questions on this here? Questions on any of this so far? And again, when we talk about solving, because it may or may not come up on the ACT, especially tomorrow, because I've not looked at any of the questions. When they talk about restrictions or extraneous solutions, given the following rational expression or the rational equation lists the possible extraneous solutions, which sounds like what in the heck are they talking about? All they're saying is what values of x will make you have a division of 0. What values of x will not work in the original problem? What values of x must be excluded? So for rational expressions, when we have these all set equal to each other, the extraneous or solutions are the values of x that will make the denominator be 0, cause you to divide by 0. Those have to be removed. If we're talking, and again, this is later chapters, we talk about square roots, even roots, extraneous solutions would make whatever numbers inside that radical be negative, because we cannot take the square root of a negative number, extraneous solution. But I think we feel good with this one here, yes? For the most part, we're going to see some more. But the biggest thing with simplifying these rational expressions, factor, and then see what's in common on top and bottom. And we can remove it out. Because this next one here, we have x squared minus x minus 12 over x squared minus 9. There's nothing that says that we have to factor the denominator first. Because if you can see, and you're able to find the factors of x squared minus x minus 9, or 12 first, the top, factor it. If you notice that the denominator, x squared minus 9, again, is a difference of perfect squares, because what times itself is x squared? And x, 9 is 3 and 3, and our signs would be opposite. Kind of the big giveaway that it's a difference of perfect squares, or possibly we have no middle term. We have no term with just x. And they're being subtracted, so x plus 3 times x minus 3. And there is no greatest common factor on top and bottom. So on top, the third term is negative, so the signs have to be opposite. And yes, the only factors of x squared are x and x. Now our factors are 12, 1 and 12, 2 and 6, 3 and 4. Only choices we have, yes? Now, 3 and 4 is going to be my first thing I'm going to look at. Because if there's something in common, something simplifies, it has to be either x plus 3 or x minus 3 on top. So I know that's a first choice, one of our first options that we can have, one of the first ones we can try. Yes? Questions on this so far? Now again, I've said it many times and I'll keep saying it, especially on the ACT. The answer choices give us a lot of hints at what's going to happen. And especially if x plus 3 and x minus 3, this was an ACT and both of them showed up in all 4 spots, we know what? 3 and 4 is not going to be the factors. Because if they were, there'd be something in common. We would reduce it, so now we're left with the others. But here, x times negative 4 is negative 4x. 3 times x is positive 3x. Negative 4x plus 3x, negative 4 plus 3 is negative 1x. That is the middle term we wanted. So we know that the x plus 3 and x plus 3 will cancel out. That also means any answer choice that has x plus 3 left, either on top or bottom, has to be removed. And what that leaves us with is x minus 4 over x minus 3. There's nothing else that we can do on top to simplify the x and 4. They have nothing in common. X and 3 doesn't have anything in common. So this here would be our answer. Restrictions. Values of x that would make the denominator be 0. And just like before, we have 2 spots. We have x plus 3 and x minus 3. With our x plus 3, we can subtract 3 from both sides. Positive 3 minus 3 is 0, leaving us with just x. Telling us that if x is negative 3, we would have a division of 0. Cannot work. With our x minus 3, we'd add 3 to both sides. Negative 3 plus 3 is 0, telling us that if x is positive 3, we'd have a division of 0. That cannot work. And again, for the most part, I'm doing these here. I'm not going to necessarily ask you to do the restrictions, especially on the homework. I just want you to be aware of what they are and how we look at them. Especially if you're looking at these here, if you get stuck on one of the problems and trying to get help and you see they keep throwing these out, this is what they're talking about. They're saying that if x, we decide to plug an x in here, we cannot use 3 and negative 3. If we do, it would give us a division of 0. Even though that x plus 3 is gone, we still list it as a restriction. It still can't work. Questions on this here? Let's look at this one. X plus 4 over x squared minus 16. Can we factor x plus 4? So again, one good thing to help or think about, when we think about factoring, greatest common factor, no matter what it is, we need to check it first. Because if there is one, and we've seen it up to this point, if we can factor greatest common factor out, it makes the numbers smaller. It makes it easier to work with. Well, x and 4 does not have anything in common. Also, the degree of it is 1. Degree is the biggest exponent attached to a variable in the expression on top. X plus 4, x is the only variable up there. Its degree is 1. It does not factor further. So that tells us the numerator is just x plus 4. There's nothing we can do to factor it. Now the denominator, x squared minus 16. We do have a power of 2, so there's a good chance it does factor. No middle term, so either difference of perfect squares or our cubes. X squared is not a perfect cube. X squared is a perfect square. It's x and x. Is 16 a perfect square? Yeah, 4 and 4. So this should factor to x plus 4 times x minus 4. Questions on how we got to this point? Now, even though I didn't write them, x plus 4 is still a set of terms. Those two are locked together. If it helps, especially when we have something like this here, to put the parentheses to remind yourself that they're locked together, do it. Because what do we have in common on top and bottom? X plus 4 and x plus 4, yes? Well, that's easy to see that the denominator is just going to be x minus 4 is the only thing left, yes? What would the numerator be? The tempting option is to say what? 0, yes? But it's not. It is 1. Because the numerator, we can think of it really as 1 times x plus 4. And as we did at the start, we could really break it up. One fraction is x plus 4 over x plus 4. The other would be 1 over x minus 4. Whenever we divide something or simplify something out on top and bottom, it reduces to 1. It will never reduce to 0. When we're simplifying on top and bottom, it's going to reduce to 1. Telling us that we have 1 over x minus 4. Now, if we want to list the restrictions, it'd be what's going to make x minus 4 be 0 and make x plus 4 be 0. Well, solve these here with x minus 4, we would add 4 to both sides, telling us that if x is equal to 4, we'd have a division of 0, so that does not work. With our x plus 4, we would minus 4, telling us that if x is negative 4, we have a division of 0. It does not work. But we'll stop there for today.